Hello everyone and welcome to another video of Vivek Learns. In the last video of PepCoding Level 1, we had solved this infix expression. So an infix expression is an expression which is understandable to humans and we can solve that particular expression using our bottom-mass rules. So the example that we saw here was something like 5 minus 2, or we had seen some examples where we had brackets also. So how did we approach this? So we iterated over the string that we have, we took the characters, we checked if the character is a digit or not. If it is a digit, then we used to put into the operand stack. If it was a closing bracket, we used to push that into the operator stack. And if it was a closing bracket, if it was an opening bracket, we used to push that into the operator stack. If we encountered a closing bracket, then we used to pop till we find an opening bracket, and we used to perform operations. So we performed operations by popping two elements from the operand stack and one operator, right? And then we used to invoke this perform operations method that we had. We used to get the result and we used to put it into the operand stack. Okay, and then for this specific case, we used to pop the closing bracket as well. So this line is popping the closing bracket. And if we had any other operations, then what we used to do is we used to check for three conditions specifically. So the first condition we saw was that for examples like 5 minus 2, we can have an empty stack as well. So the stack should not be empty when we are trying to push into the operand stack. The second thing was that the um, operator stack should not have a closing bracket. So if we encounter not a closing bracket, an opening bracket. So if we encounter an opening bracket, we must stop the iteration there. And then what we saw was this priority or precedence logic. So if in the stack we have an operator which is having greater priority. So if we have this, we have the logic to get the priority from here, and we used to get the priority of the operator present in the stack. If the operator present in the stack has higher priority, then we used to perform that operation first. Meaning, like if we had multiplication and division in the stack, and then we had a character which comes in and has addition, then we used to first perform multiplication and division, right? Because that's how the priority works. And even if we had equal priority, let's say in the stack we had multiplication, and in the CH we used to get division, what we used to do is that we used to perform the multiplication. And why did we used to do that? We used to do that because we have to solve the left side first, and then we had to solve the right side, right? So yeah, so we perform the operations in a similar way, like this logic is similar. So we used to pop two operands, and then we have to pop the operator. Then we have to perform the operations by having v1 operator v2, right? So if we have a look in this, we have v1 operator v2, and then at last, if the and in this condition specifically, we used to push the operator as well after we perform the operations. And at the last, we had this condition, right? Where if we have any elements in the operator stack, we should perform operations. So the operator stack should be empty, but we will have one element in the operand stack, which is our result. So the result was operand stack, and we used to pop the operand stack to get the result. So this was about the last problem that we did. Now let's try to solve the next question that we have, which is we have solved this infix evaluation. Let's try to solve Next question, which is prefix evaluation and conversion. Prefix and postfix evaluation and conversion. So let's try to see this question. You are given a postfix question, postfix expression. You are required to evaluate and print its values. So before we go to this, let's try to understand what is a postfix question, postfix expression that we have, and what is a prefix. Like we will cover these topics for now today, and how do we convert from a postfix to a prefix. Okay, so yeah, so let's first have a prefix as an infix expression. So suppose this is the infix expression that we have, and the prefix expression for this, how will we get it? For the prefix expression we will get by having the operators first. So I'll have plus as the operator first and then AB as the operands at the last. And how will I get the postfix expression of this? So I'll get the postfix expression of this by having the operands first. So I'll have AB first and then the operator. So this is how I'll like this is a simple example of how I'll get the prefix and the postfix. Okay, so this infix expression that we have, it's understandable by humans. But this prefix and postfix, these expressions are understandable to machines. So we may have a problem where we have to convert this prefix infix solution to a prefix or a postfix. So that's how we will, kind of approach the problem statement that we have. So I will try to have an infix solution converted into a prefix or a postfix. Okay. Yeah, so let's try to have some complicated problem. Let's erase this. So let's say we have an expression which is A times B plus C B minus C divided by D plus E. So how will we find the prefix and the postfix for these? So what we can do is that we can have an expression diagram kind of thing for here. So for this we'll have two conditions maybe. So we'll solve from here, right? So here we'll have minus and then BC, and then after that we perform the multiplication. So this is kind of an expression diagram that we draw, which is of A. Then we have the division. Then we have D, to which we divide, right? Then we have plus sign, to which we have E. Yeah, so this is the kind of a rough, um, and I know this diagram looks very weird. Let me just correct it somehow. So, yeah, so what we did was we found out the expression tree kind of for this expression. So we'll have this expression evaluated first, right? So we'll have minus BC. Then we go to the left side and evaluate that expression. So we'll have multiplication, then we'll have division of whatever the result we get from this, and we'll have division with D. Then we'll have addition with E. So that's how we'll get this expression tree. So how will we get the prefix or the postfix expressions? So what we'll have to do is that we'll have to draw an Euler's path for this expression, and whatever are at the left side or at the pre side, we will have those elements as the prefix. So let's try to draw the Euler's path first. So I can draw Euler's path in this manner, somewhat like this. So this is minus sign, right? Yeah. Yep. This is how I'll draw Euler's path. And how will I have the pre-expression from this Euler's path? So what we can do to get the pre-expression, whenever we are passing on the left side of an operator or an operand, we have to print it to get the prefix expression. So we are passing from the left side of plus, then minus, division, and then multiplication, right? So this is the pre-path that we are trying to do. So plus division, multiplication, then we'll have A, then we come here, then we have when we go through the left part of B. So we'll go through left part of B. Okay, before that we go through the left part of this subtraction also, right? So we'll have minus B. Okay. First we'll go through the minus sign that is printed and then B. Then we'll go to the left part of C. And then we'll go to the left part of D. And then to the left part of E. So this is the prefix expression that we have, which is plus division multiplication A minus B and C divided by C D E, right? And now let's try to find the postfix expression. So how will we get the postfix expression? We can get the postfix expression by following the Euler's path, and having whenever we are in the post area. Okay, so what is the post area? So this is kind of the pre-area, we can say. For this is the in area and this is the kind of post area that we have for this expression. So this is the pre-area for this plus sign. This is the pre-area. This is the in area and this is the post area. Yeah, so we'll go through the expression tree and we'll try to find out the post expression. So we start the iteration from here. Then the first variable that we encounter is A. So we'll have A printed because we encounter A in the post area. Then we'll have this multiple. We'll have in area as this, right? We'll have in area as uh, this area as n area. So we'll not have this. Then we'll have this B. Then we go through this. So this is the in area for this minus sign. So we'll go through this loop like this. We'll have C printed. Then we'll have minus sign, the post area of the minus sign. Then we'll have post area of the multiplication sign. And we'll have in kind of in area of this division sign, right? So we'll have the post area of D. So we print D. Then we'll have the post area of this slash, which is division sign. Then we'll have E printed and then plus sign. So this is how we'll get the pre and the post pre, pre post fix expressions, prefix and the post fix expressions. So anyhow, we are not here to discuss this. Like we are given an infix expression and we are told to find the prefix and the postfix expression. So how will we approach that? So let's consider an example. Let's say we'll have A times B minus C divided by D plus E. So what we will do is that we will have one operator stack and we will have two stacks. One is prefix stack and one is postfix stack. Okay, so and we will follow all these rules, but the only thing different is we'll have to, this perform operations. So for the prefix, we'll have a perform operation as, for the prefix, what do? We print operators first. So we'll have operator and then operand 1, operand 2. And for the postfix, what we do is the operation that we perform will be operand 1, operand 2, and then operator. So this is the operation that we will be performing in the perform operations. Like earlier, what we used to do is that we used to perform addition, multiplication, division, or subtraction based on the operator. But we just have to print it in a string and then we'll append or keep on appending or prepending the string. And that's how we'll approach this. So let's say we'll iterate over this. So we'll have A. So A will be pushed both in the prefix and the postfix stacks. Then we'll have multiplication sign. Then if we encounter an opening bracket, we just push it into the operator stack. Then we'll have B. So B is also pushed in both. So instead of us pushing once into the operand stack, we are pushing in both the stacks, in the prefix as well as the postfix stacks. Yeah. So after this, we encounter B. After encountering B, we encounter subtraction sign. So we go through this subtraction sign. Then we encounter C. So we put C. And this subtraction sign, it will not pop. This because we have an expression in the, uh, not an expression, and condition in the while loop. So in the while loop, we have this condition, right? So if operator stack dot peak is opening bracket, we don't perform the operation, right? Yeah. And then C is inserted in both the stacks. Then we encounter this closing bracket. So once we encounter a closing bracket, what do? We pop. So we pop this operator. And for the prefix, what we do? We have the expression which is plus and then the operands. So the operands will be V1, V2. So this will be V1 and this will be V2. So we'll have plus BC as the operator, B and C. Uh, yeah. So okay, where did we insert the minus? Yeah, so okay, so we have the minus, right? Just a minute. Yeah, so we have this minus sign here and we had this C operator in both the stacks. And once we encounter this closing bracket, what we have to do is that we have to pop from the operator stack. We pop the minus sign and then we have to pop um, from the pre stack. So we'll pop from the P stack. So the expression that we will get is minus BC, as we are doing this as we have this as V1 and this as V2. So we'll have V1, V2. And then for the postfix, we'll have V1, BC, and then the operator. Yeah, so we'll pop these and we'll get this right. And then we have popped this to perform the operation, and then we pop this to uh, um, when we iterate over, when we encounter a closing bracket, we evaluate this expression and then we pop. We don't evaluate this expression like we had done for the infix. We just find the pre and the postfix expression for this, and then we'll, you know, have have those printed. Then we iterate further, and then we encounter this slash. So once we encounter this division sign, we'll see that an operator of equal precedence is present. So what we do is we pop it. Once we pop it, okay, and we also insert this minus BC here, right? I forgot to insert that. And we have this. So we pop this multiplication sign. So for the prefix, we will have multiplication and then v1, v2. So we'll have multiplication and then we'll have a and then this minus bc. Okay, and this will be inserted into the stack. So we'll have multiplication a bc. And for the postfix, what we do is we have the operands first, a, bc minus, and then we'll have the multiplication sign. So we'll have v1, v2, and then the operator, sorry. So yeah, and then the slash is inserted. Once the slash is inserted, let me have this here, and then multiplication. Yep. Once we have slash inserted, we continue the iteration, and when we insert d, so for d is inserted in both the stacks, prefix as well as the postfix stacks. Then we'll insert the plus sign. So before inserting the plus sign, we will check if an operator of higher precedence is present in the operator stack, and it is present. So what we do is that for the prefix expression, we have the operator which is popped from here, and then we'll have v1, v2. So we'll have v1 as a minus bc, and then we'll have d, correct? And this will be persisted into the stack. For the postfix, we'll have the operator at the last, right? So we'll have b1, v1, then v2, then the operator. Yep. And then this plus sign is inserted into the stack. Then e is inserted into the stack. So yeah, let's insert e into the stack. Okay. And then at last we'll have a loop which will run till this operator stack is empty. So till the operator stack is empty, we'll perform operations. And the operation that we perform for pre is we pop this operator, we pop it, and we perform v1, v2. So we pop plus, and then we perform v1, v2. So v1 is this expression that we have here, and then v2 is e. So this is the prefix expression. For the postfix expression, we'll have the operator which is popped plus is added at the left, right? So we'll have this operator first, v1, then v2 operator, e, and then the plus sign. Yeah. So this is how we will evaluate the prefix and the postfix expressions that we have. So the rules will be same, only the logic in the perform operations uh, method will be varied. Okay. Uh, we don't have a method for this perform operations as of now, so we can create a method for perform operations in pre and perform operations in post. My bad. This is post. Yeah. So let's continue. Let's try the coding part now for the pre and post expression conversion. Pre and post fix expressions. Post fix conversion. So we have this operator stack which we'll need, and we'll need two more stacks, right? A stack of string for pre, and stack of string for post as well. Yeah, so we'll go through this logic again. Yep. So the method that we have is for priorities. So we can have mm, all this logic, like these two if conditions in one statement only, and we can have these two if conditions in one statement. The reason that we had it in different if statement was we had to uh, have the same logic implemented here as well, but we'll have a different operation logic. Okay, so what do we do? We will check right first if. So we'll have if condition first, and then we'll check if it is in our range, like if it is a digit or not. But the only difference is here we'll have to check if it is between the range that we have, and ch is greater than equal to this, and ch is less than equal to z, or we'll have these conditions here because we are not dealing with only digits. We'll deal with alphabets also. Then we'll have for capital A to Z. Then we'll have for digits as well. So what if we encounter uh, such such digits or alphabets? We push into the stack. We push into the pre-stack. We have to push a string. So we'll push ch plus this kind of a workaround to have this a character converted into a string, right? So we'll just append this empty string to convert that character to string. And in the else if condition, we'll have the first condition that we saw was if we encounter a opening bracket, we just have to push. We don't have to check any priority or anything, right? So we just push it into the operator stack. We push, what do we push? We push the ch, right? Yeah. And the third condition that we saw was what if we encounter a closing bracket. So if we encounter a closing bracket, we perform the operations till we encounter a opening bracket. So we'll have a while loop to perform the operations, and then we pop the opening bracket. This is popping the opening bracket. So we will perform operations till we'll have a peak here, which is opening bracket, right? Yeah. So we'll perform operation here. So what do we do in the perform operations? We'll get the operator, then we'll get the elements as well. So we get the elements from pre-stack, we'll get string, right? We'll have string v1. So first we'll get v2, right, on the first pop. Then we'll give these to the perform operators. Give v1, v2, and the operator. So this perform operations will have to change now. This perform operations should return a string. It will take what it will take a string, right, as v1, v2. Yeah, because we'll get from that from the pre or the post stack, and we have the character, and we'll just have, I think we can create two methods, perform pre operation, then we'll have another for perform post operations. Like that is what I think. Yeah. So these will have separate responsibilities. So in the, let's say in the future, we have to change the logic for pre-operation or post-operation. So we'll have changes in this method only, and we will not disturb the other code. So what do we return from here? We return v1. Okay, so for pre-operations, we have operator first plus v1 plus v2, right? This is what to return. And for the post, what do we do? For the post, we return v1, v2, and then the operator. Yep. Yep. So we'll call this pre-operations, perform pre-operations. Then we'll get something, right? We'll get a string back. Pre-string, let's say. Then we'll have to push this pre-string into the pre-stack. Then we'll have similar thing that we do for post. So we'll push this post into the post stack. Yep. So we get the operands from the pre-stack, and okay, so for the post stack we'll have to get it from the post stack, right? Okay, so yeah, I don't think this is a good idea because we are taking from the pre-stack and then we'll just have post stack. We can have the logic for the, we can give the pre-stack as well here, right? Yeah, we can give the pre-stack here as well. So I don't want this logic here. What can we do else? Yeah, I think we should do that. We have the stack of string. We'll get v1 v2 from the pre-stack. So v1 will be, so first we'll get v2, right, and is equals to pre-stack. Similarly we'll have v2 v1. What is the error that we are getting? Duplicate variables. Oh, okay. So we'll not have this v1 v2, let's say. Then we just give the operator and the stack. If we give the operator and the stack, we'll get the pre for this in the pre operation. Okay, so we'll change this. We'll just give operator and the stack. Yep. Then we'll have operator plus v1 v2, right? And then in postfix we'll have operator and post stack. Then we'll have this same logic here. The only difference is we have post stack here. Yep. Give post stack from here as well. Yeah, so the operation that we perform is we'll get the operator and we'll get this pre-string from here. We push that pre-string into the pre-stack. Similarly, we get the post string from this perform post operation. Yep. And we'll have the else if condition. One more else if condition, right? Or where we have those operators like plus minus division. So we had that written here. So let me copy that. So here what we need to do is that we need to check 2 3 conditions, right? So we have to keep on iterating till we find an till if we have an empty stack or so if we encounter such operations, first we'll have to check the priority. So we'll check the priority first. Priority of ch if it is less than or equal to. So what we check is if the element in the stack has greater or equal priority, then we evaluate that first, right? So that is the logic that we are writing. So priority of operator stack dot peak. So we cannot have this peak operation on an empty stack. So we'll have an extra check that operator stack dot is empty should not be empty, right? And also we have one other condition. So if we encounter an opening bracket, we'll we don't have to iterate then, right? We'll have to stop the iteration then. So we'll write that condition. So if and operator stack dot peak, if this is equals to an opening, so this if it is an opening bracket, right? Then we'll have to stop the iteration. And once we perform operation here, we'll have to you know insert that element as well. So we'll insert in the operator stack. So this is the same operation that we perform. We'll get the operator in the pre-string, we push into the pre-stack. This is the same operation. Then at last, if the operator stack is not empty, then we'll iterate. We'll iterate till it is empty. Then finally, we have the pre and the postfix. So we'll get the prefix by the pre-stack, right? Pre-stack dot pop. Have poststack dot pop to get the postfix expression. Yep. Let's go through this logic once more. So if we encounter a character which is A to Z or capital A to Z or a digit, then we push into the pre and the post stack, right? If we encounter an opening bracket, then we push. If we encounter a closing bracket, then we pop. We pop till we find an opening bracket and we perform the operations. So we'll get the elements from the pre and the post stack and we'll have the perform operations like operator v1 v2 or v1 plus v2 and then the operator. Yeah, and in the else if condition we'll have this, right? In the else if, yeah. So here we check the priority of the operators. If the priority of the operator in the stack is higher or equal, then we evaluate the expression in the stack first. How do we evaluate? We evaluate meaning we form the prefix and the postfix of that operands and the operator first. Okay. Yeah, so this is how we will approach this question. Let's try to run it once for a simple example. So let's have a plus b. Yeah, so we have the correct answer. Let's try another iteration for a minus b. So we'll have minus ab correct and ab minus. Yep. Let's try to solve it for a complex one that we did right by d plus e. And we got an empty stack exception on line number. Where did we get that? On line number 30. Okay, strange. And on line number 80. Okay, but this should not be the case. Perform pre-operation. So we are having the pre-stack here. So we pop first v2 then v1, right? Let me check. Yep. So we'll have a times in bracket d minus c divided by d plus e. The stack is having 84 elements. Not 84 elements, it is at this line, which is 80th. Let me run it once more. You have to be sure. Yeah, let's go here. So we are not able to pop from here basically. So we'll have some extra conditions. Um, or we can So whenever the stack is empty, like I think at that time it is trying to, have this pop condition, right? So if stack is empty, then we'll just have to return an empty string, right? But for which case is it trying to, you know, have this empty stack? Um, so if ch is greater than or less than z, ch is, I think this condition is not being satisfied, like it is not able to push this. So if ch is greater than a equals to a, or ch is, so let's try to print here something. So let's try to run it for C. Yeah, so we are able to insert A. Mm, then we are insert B. We are inserting B. So for an opening bracket, we have it in the stack, right? So we have inserted A, B, C. Okay. Then we'll have this operator stack dot peak is not equals to. So we are facing some issues when we are, trying to, when we are in this logic. Okay. So we'll perform the operation is somewhat here. For inside insertion of C, so C is inserted. So let's see. Mm, so C, if C is inserted, let's try to have this here, have the code here, and let's try to evaluate what is wrong. So let's try to have this expression. Oops, the expression is already here. Yep. Let me. Yep. So in the pre-stack, first we'll have A, then we'll have A here as well. Then we'll have multiplication here. Then we'll have an opening bracket here. Then B is inserted in both the stacks. So B is inserted in both the stacks. Then subtraction is inserted. Then C is inserted in both the stacks. And then we'll encounter the closing bracket. So this is where the issue is. Once we encounter the closing bracket, we pop one element from ch and then we'll give it to, so the operator is first minus here, and then from the pre-stack what we do is we go into this perform operations and we'll have v1 v2. So v1 is b and c, so we'll have v1 v2 like b and c. So we'll first have b c minus, right, or minus bc because it is a prefix. So this is the expression that will get minus bc, the pre-expression, correct, from the first. And then we get that and then we push it into the stack. Okay. And then we'll go into the post. So we'll give the same operator to the post and we'll give the post stack. And in the post stack we are popping. we pop v2 v1 and then we have v1 v2. So we'll have we pop v2 v1 and then we'll have bc minus as the operation. Okay, so this is the only thing that gets popped here, right? So let me check the conditions here. If we encounter a closing bracket, we do operator stack dot peak till we encounter a opening bracket. So while this is true, we'll perform this operation. But why are we? So we are inserting into the stacks, right? We are inserting in both the stacks. Inside insertion of B, and then we are also inserting C. But we are not. Okay, so we'll have the insertion in the operator stack for this, right? Yep. What? How else can we debug? We can debug by having the pre-stack and the post-stack printed. We can have the post-stack before calling this. Let's try to run it once for the same expression. Okay, so in the pre-stack we do have AB. Okay, so we'll have. Okay, let's have a look at this. We'll have the opening bracket inserted, in the pre-stack, then AB. But we don't want to insert the opening bracket, right? So how did this opening bracket get here? In the pre-stack we had this. So somewhere we have an error, so we are inserting A, B, C. So this is the first element and this is the second one. Yep. So in the pre-stack we already have this AB bracket, AB, opening bracket AB. But how did we get that is the question. Let's have those here as well. Let's have this logic here. So whenever we are into a multiplication, at that time I think we are getting some. Let's check. Yeah, so we have A, B, A, B in the B and then A, right? Then we insert C. Then we, okay, so while inserting C, so once C is inserted, then we have the problem. So once C is inserted, when we are trying to insert C, let's check the logic when we are trying to insert C. After insertion of C, okay, then we have encountered this bracket. So it is fine till here. The pre and the post tags are fine here. So we have B and then A, and we have this opening bracket is in the operator stack. So yeah, we don't have to consider the opening bracket, right? So we can have some condition around that, right? So where can we have this condition? So we basically the thing is we are doing it right, but we don't want this opening bracket. We have AB. This opening bracket is kind of the blocker here. So let me, yeah, so what we can do is that we can think about this question in the later part of the video. Let me pause it once. Yep. Yes, I'm back. So the problem that we can see here is somehow A and B are being inserted. Okay, and this minus sign is not. Okay. Yeah, so if operator stack dot peak is equals to, so this is somehow causing the error. So I think this should be not be equal to, right? So if we encounter an opening bracket, we should not iterate. We should not perform this operation, right? So yeah, I think that was the catch that we were missing. Let's try to, yeah. So we get the prefix and the postfix. Let me remove these lines. So that is the condition we had in the earlier problem as well, right? We can check that once. So this condition operator stack dot peak is not equals to in the previous problem. Yeah. So somehow we messed it up and we had the double equals instead of not equals. Let's run it once for again for this, right? Yeah, so this is the pre-expression and this is the postfix expression that we have. So we can compare it once. You have to be sure. So we had it right. Yeah, so this was the answer that we had. Yep, this one, right? Yeah, so these are same. Let's do it once for the post expression as well. Yep. Yeah, so that was all for this video. Let me remove this lines also. Yep. So yeah, let's go through a summary of this video, right? So if we encounter any character or a digit, right? Any not any character, any alphabet or a digit, then we push into both the stacks, pre-stack as well as the post stack. If we encounter a closing bracket, we push that into the operator stack. If we encounter a closing bracket, we pop till we find an opening bracket. Okay, and we perform the operations while popping. Okay, so we are popping here from the pre and the post track, and then we do operator v1 v2, and for the post we do v1 v2 operator, right? So after that, the third condition we have was if we get any operator. So if we get any operator, we'll have three checks which are important, and we messed up in the second check that we had. So yeah, in the second check that we had, uh, in the second check we have is that we have to peek first. If it was a closing bracket. If it is a closing bracket, then we don't have to continue, we don't have to perform the operations that we are performing, right? The logic that we have here. And we also check the priority. So if an element in the stack is having higher priority, then we have to perform that operation first. By performing operation meaning, I'll have to evaluate that prefix or the postfix expression first. Okay. And we'll have this additional condition as well, because if the stack is empty, then this operator stack.peak would give an empty stack exception. And there are some special cases where we have an empty stack, but we have to insert it, yeah. So this not empty condition handles that. Yeah, so we have went to this three if conditions or three rules if you want to say, and then we just iterate till the operator stack is empty and we perform operations. Yeah, so that was all for this video. In this video we converted an infix expression to a prefix and a postfix expression. Yeah, so see you guys in the next one. Thank you.